Well, hi, everyone, and welcome to AstroNights. We have a fascinating presentation planned for you again tonight, and we're very excited that you chose to join us. Our presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your question until the end, although because it just might get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available there, so just sit back and enjoy the program. Whether you're joining us on Zoom or YouTube, we recommend taking a moment to locate the full screen mode in your app for the best AstroNights viewing experience. All of the websites and resources that we'll be discussing during our program are available on our website. So don't worry about rushing to write them down, just relax and enjoy the program. The links will be waiting for you when you're ready. And now I would like to introduce you to our presenter, Mary McDonald. Mary is the Planetarium Programs Manager at the FSU Planetarium, and I know that she's very anxious to get started. So, Mary?
Good evening, everyone. Thank you, Bruce.
Sure.
So my name is Mary, and I am going to be your guide for AstroNights tonight. Before we get started, I'm going to ask everybody a question. I just found out recently that the questions I'm asking cannot be seen by the YouTube viewers. So I'm going to put this up on the screen for everyone. So this question is kind of relating to our presentation tonight and also just whatever is going on in the world right now. If any of you have joined us for previous AstroNights, this question's a little bit different. There's not really a right or wrong answer. So it's just something to talk about. For those of you that are at home together, watching as a group, anytime I'm asking a question, I really want you all to discuss the question together with each other. So this is our first question. So what is the first thing you look for in nature that tells you that spring is starting? So take a look at the choices there. But for those of you that are joining on Zoom, I am actually going to ask this as a poll so you can participate. Those of you that are not watching through Zoom, those of you that are on YouTube, just know that there is a little bit more interaction available if you join by Zoom. So consider doing that next time, or maybe you could even try tonight. All right, so ready? I'm going to launch the poll for those of you on Zoom. So start putting in your responses, but everybody should just be talking about the question, get a little bit of the conversation started. All right, we've got some responses coming in. All right, we are going to wrap up this poll in 3, 2, 1. I'm ending the poll. All right, so I'm going to share the responses that people had in just a moment. But first, we're going to switch over to our main event tonight. So the next thing you're going to be seeing on your screen is a lovely view of the night sky. So everybody should be looking at a nice view of the night sky. This is actually the sky that you will see at 7:45 this evening. So that's what everybody should be seeing. All right. So we're going to take a look at some things in the night sky that you will see in the real sky if you head outside tonight. It might be a little bit cloudy, and I've heard there's some thunderstorms coming, so you might not be able to see the sky tonight, but the sky shouldn't look too different for the next few days. So we hope you all find some time in the next couple of days to get outside and look at the real sky. That's kind of the point of AstroNights, is to give you a little bit of inspiration to get out there and explore. Okay, so with that, I'm going to share the results of the poll. So let's see. So those of you on Zoom should be able to see these results, but a lot of people said they see more birds everywhere. A lot of people, the biggest answer was trees and flowers start to bloom. A few people said no more snow, and that is usually true. But I think we found this year we had some snow this month in May, so that's definitely not always true. Temperature gets warmer. Yeah, that usually happens. So like I said, none of these answers are really wrong. There is actually one answer, though, that is not exactly true, and that is a full moon. So you definitely might see a full moon in springtime, but you actually are going to see a full moon every single month. The moon is full every 29 and a half days. So you'll see full moons in spring, summer, fall, and winter, and it doesn't have anything to do with the seasons. So that one is not exactly a sign of spring. But also, I noticed that a lot of people did not choose patterns in the stars. And that makes a lot of sense because we don't really spend a lot of time looking at patterns in the stars. And, you know, we also have calendars, so we kind of know when spring is coming. But one of the main things we're going to talk about today is that there are actually different patterns in the stars in different seasons. And this is a way that people used to use to help them identify the change in season. All right, so everyone, let's now take a look at our lovely night sky. So as you can see in this view, we're basically facing south, and there's nothing really that can help you figure out which way is south. Sometimes the moon is the best way to figure it out, but you may know that most smartphones have a compass app. So if you can figure out how to use that to figure out which way from your house faces south, which way faces east and west, and that'll help you determine where to look in the night sky. And I'm going to remember to do one thing before we get started. I'm going to hide my video so that we're only looking at the night sky. All right, and just a quick reminder, everyone, you should be in full screen mode. That's your best way to view the presentation. All right, so the sky is about 7:45 right now. So this is what you're going to see at around 7:45. And you might see the sun beginning to set over in the west. And you also might see a nice bright light over here. That is the planet Venus. So if any of you joined us for previous Astro Nights, you may have learned a little bit about Venus. And I want to remind everyone that those recordings can be found on our webpage, our AstroNights webpage, which I'll go over again at the end of the program, and also on our YouTube channel. So you can see some of the past AstroNights presentations that we've done, and this one tonight will also be available pretty much as soon as the presentation's over. All right, I've taken us now forward to about 10 minutes after 9. So I think I've already pointed out, and if you were keeping your eye on it, the planet Venus over there. We're not going to really talk about Venus tonight. Tonight, we're not going to talk about any planets at all. We're going to focus on the stars. And in particular, we're going to talk about patterns in the stars, also known as constellations. So when you don't really look too carefully at the stars, you might think that they look the same every night. But if you look carefully, you'll see that they don't. Now, if I asked you is this one little star, is this the same every night? Can you look for that one every night? That would be difficult. One single star is hard to identify. And that's why we like to look for patterns in the stars. So we're going to start tonight by looking for one of these patterns, one of the constellations, and let's get right to it. So straight ahead here in the southwest, this is the constellation we're going to look at tonight. And I want you to look with me for some familiar patterns. So I want you to follow my arrow. And I want to see if you can see this shape. To me, it looks like a backwards question mark. Right there, okay? So again, those of you watching at home together, see if you can see that shape. Okay, and then just to the left of it over here, we're gonna look for another shape, really simple, a little triangle, a right triangle. Okay, so you got the backwards question mark and we have the right triangle. Now, maybe that pattern looked like something different to you, and that is totally okay. So did anybody out there think that that looked like a lion? Anyone? Well, to someone a long time ago, that's what they thought it looked like. And this is actually the constellation Leo. And you don't really need to know too much Latin to know that that means the lion. So this is one of the constellations, and Leo is a nice one. It is sometimes called the bringer of spring. And that's because when you first start to see Leo in your sky, that's when you know spring is coming. So if anyone's been looking at the sky a lot recently, if you've been staying up late, you would have started to see Leo in the late evening a few months ago. So just a few months ago, you would have started to catch a glimpse of Leo. And now that we're in the middle of spring, you can see Leo dead center in the sky for most of the night because it is the spring constellation. And this is something that helps us explain why the constellations became so well known. They were very important to people in ancient times. Before there were organized calendars and clocks, people would look to nature to help them identify the change in season. And once they would start seeing Leo in their night sky, they would know that spring is coming. And this is very important because it would let people know that it was time to plant crops. Or later, when winter was coming, they would know to put things away. So this is why the constellations became so prevalent, and not just the ones we have today. Cultures all over the world had different constellations, and they mostly all used them for this purpose, to help them mark the seasons. All right, now there is one other spring thing in the sky, and it's not a constellation, it's just one single star. It's sometimes called the spring star. So it's called that because it is the brightest star in the sky in springtime. So I want you all to look at your screen and see if you can pick out which star appears the brightest to you. So everybody take a look. Which star appears the brightest? And I want to take a moment to remind you that there's something that's a little bit unrealistic about these stars that you see. They're a little bit exaggerated in terms of their size and their color. So the software uses size to indicate which ones are the brightest. So in the real sky, the stars are not going to look different sizes. They're just going to be different brightnesses. All right, so now I've already given you a hint because some of you might have thought at first that this is the brightest thing in the sky, and you are correct, it is, but it's not a star, it's Venus. Did anybody think that this was the brightest star in the sky? Well, very good eyes if you thought that. That is one of the brightest stars, but not exactly the number one brightest. So the number one brightest, did anyone guess it was this one up here? That's it, you're correct. So this is the brightest star. And when you go outside and look at the real sky, this star is going to be a lot brighter than all the others. So it's probably going to be pretty easy for you to find it. However, if you're not sure, oh, and I should tell you what this star is called. This star is called Arcturus, the spring star. Now, if you see a really bright star and you think it might be Arcturus, but you're not sure, I can teach you a trick to really let you know for sure if it is. So we're going to take a look we're going to find out how to do this trick. Okay. And if any of you were at the last AstroNights, you have an advantage. You already know because we actually learned this last time. So the trick to identifying Arcturus lies with another pattern of stars. So we're going to turn around and face north. And those of you who may have been at the last presentation, you might know what's coming. So there was a very well-known pattern of stars in the north that we looked at last time. And whether or not you were there, it was the Big Dipper. So really quick, if you think you know what the Big Dipper looks like, see if you can spot it in the northern part of the sky right now. I'm going to give a hint. It's almost right there in the north, but it's pretty high up in the sky. So start here at north, go way up high in the sky, and there it is, the 7 stars of the Big Dipper. Very good, everybody. So if you remember last time that we talked about the Big Dipper, we said the Big Dipper has the handle part, and then it has the scoop part. Well, today we're going to look at the handle, and the handle appears to be curved. So a curve, another word for that is arc. So the trick to finding Arcturus is you want to follow the arc to Arcturus. Arc to Arcturus. And there it is. So if you see a really bright star in the sky, it just might be the star Arcturus. So go out and see if you can find the Big Dipper and use this trick to confirm. All right. I'm going to go back to the view of Leo. And Arcturus. And that's just a little tour of the highlights of the springtime sky. So these are some of the most noticeable things in the sky right now. Now, there's a reason I chose this for the topic tonight. I chose to talk about Leo because Leo is the constellation of the month for a citizen science project called Globe at Night. So citizen science, it's a form of science where people from all over the world study the world around them, collect data, and submit it to these huge data collection efforts. It's like crowdsourcing for science. And this particular project, Globe at Night, is aimed at studying the idea of light pollution. So I may have mentioned light pollution in previous AstroNights, but I don't think I've really explained what it is. And I'm a little bit curious to hear what you all think. So that's my next question. What is light pollution? And for those of you in the Zoom, I'm actually going to give you a little poll. So go ahead if you're in Zoom. Let's see your responses. What is light pollution? If you're not on the Zoom, it's not a very complicated poll. That's really just all it is. What is light pollution? So discuss it among yourselves. All right, getting a few responses. What is light pollution? And I'm going to leave the poll up for 3, 2, 1, and that's it. Okay, wow. So this poll showed me that a lot of you have a pretty good idea of what light pollution is. Most of you were aware that light pollution is artificial light from human sources. So it doesn't have to do with pollution in the way that we usually talk about it, like trash or other harmful things in the environment. It is actually literally light. So light that comes from things like streetlights and cars and buildings that are on at night. That light goes in every direction, and unfortunately, it also goes up and that makes it difficult to see the light of the stars. So different parts of the world have different amounts of light pollution, and I'm actually going to take a quick moment to show you a really cool visualization using another software that we have called the Layered Earth. So this is a visualization known as the black marble, and it shows you lit up in white where there is light on at night as seen by satellites orbiting the Earth. And you can see that even just within the United States, there's a lot of variation, that you see a lot of light pollution in some areas and less light pollution in others. So for those of you that are here with us in Eastern Massachusetts, you might see that unfortunately, this does appear to be an area where there is a lot of light pollution. But even just getting a small distance away from the city can make a big difference. And that's what Globe at Night really wants to do, is it wants to see how light pollution is really different as seen by people on the ground. Okay, so the project, and I'm going back to the night sky, it's asking you to look at Leo and identify how many stars you can see. So we do have a link to this project if you want to actually participate and submit data. It might not be the right activity for the youngest viewers, but if you don't want to actually do the official data collection, just go outside one night, see if you can see Leo, and see if you can see all of these stars. See if you can make out all, what do we have? 1, 2, 3, 4, 5, 6, 7, 7 stars of the question mark, 3 stars of the triangle, or perhaps if you have a lot of light pollution, you might only be able to see perhaps the brightest star, Regulus, which is right there. All right, so that's my assignment for you all, is to, at the very least, go ahead and try to find Leo in your sky. Now, we mentioned that Leo is the bringer of spring. It's a spring constellation. I'm going to turn us towards east, and we are going to let some time pass. So remember, everyone, it's about 10 minutes after 9. So all of the things we just saw in the sky, you can see at that time. But now we're going to let some more time pass. And you'll notice that as the night goes on, some of the stars and other things that we saw earlier are going to disappear in the west. But meanwhile, new stars, not new stars, but stars we haven't seen yet, are coming up in the east. So it's around 10:30 now, and coming up in the east, we see a couple of bright stars. This one here is called Vega. Coming up behind it are the stars Deneb and Altair, making a nice little triangle. And by the way, this is around, we'll go to around midnight. So this is midnight tonight. You see this triangle of 3 bright stars, and it is known as the summer triangle. So as you might guess, this is a pattern that is most easily visible in summer. But you can see here that it is not, you don't have to wait till summer to see it. You can see it now, but you just have to stay up pretty late. So basically each night, the summer triangle is going to come up a little bit earlier, every single night a little bit earlier, until it's the most prominent pattern in the night sky. So that's just a little introduction to how the stars appear different throughout the year. And don't forget that this is all because of the Earth's motion. We just witnessed a little bit of the Earth's motion during one day, how the Earth rotates. But the reason why we see different stars at different times of the year is because the Earth is also making a big circle around the sun. So basically our view of the stars changes. All right, so I'm gonna now invite people who are in the Zoom to go ahead and start jumping into the Q&A. So find the Q&A feature in your Zoom window, and let's see some questions that have come up during the presentation. And while you're taking your time to do that, to type in your questions, I would like to take a quick break to remind everyone of our website. So the Kristen McAuliffe Center's main website is cm-center.org. So there you have it right there. And as you can see, everything that we are recommending for everyone who's learning at home right now, we've put straight dead center on our homepage. So these are all really useful things for at-home learning. And everything that the planetarium has put together is under From the Dome to Your Home. So this is where you'll find a lot of the things that we've presented that's based on our work in the planetarium. And this is where you'll find all the AstroNights stuff. So every event has its own event page. Here's tonight, the spring star. And if you click on the event page, you can find, this is where you'll find the recording later. And this is where we've listed all the resources that have to do with the things we've talked about tonight. So I hope you will all check that out at some point later. And now let's go back to the night sky. And I'm going to take a look at some of the questions that have come in. All right. So I'm going to go with one of the first questions that came in. It is, who named the constellations and stars? That's actually a really interesting question. So I think I've already mentioned that there are many, many different constellations and other patterns that have been named by different cultures around the world. So the constellations that we typically talk about as astronomers, they come from the peoples of ancient Greece and Rome. So Leo is one of those, and those are the 88 official constellations. And you can see in their names and in the mythology that they reference that they represent, as I said, Greece and Rome. So I'll point out some of the ones you're looking at right now. We have the constellation Lyra right there. We have Aquila and Cygnus, again, more Latin. So the Summer Triangle is not a real constellation, or it's not an official constellation, but each one of these is a part of one. So Cygnus, they're all Latin, that's swan, eagle. But you can see that the names of the stars are a little bit different. So a lot of the constellations that we use are from Greece and Rome, Latin language, but the names of the stars are a little bit different. A lot of those come from Arabic because around the same time and also before and after, astronomers in the ancient Middle East were doing a lot of work that we still use today, and that's where a lot of our star names that we use today come from. But I do want to just repeat that just because these are the constellations that have become official and these are the star names that have become official, that doesn't mean that other cultures didn't come up with their own as well. They just didn't become the official ones. All right, so that's the first question. I'm going to take a quick moment to bring my video back up, if I may, because I think that would be nice. Okay, so that one is done. Okay. So the question I'm going to go to next is, were we viewing the screen in your planetarium or was it generated by software? That's an interesting question. The answer could technically be both. So if anyone has been to the Framingham State University Planetarium or any digital planetarium, the views that you see are generated by software. And it's a really, really advanced software that has the accurate positions of all stars and planets for hundreds of thousands of years in the past and future. So yes, planetariums in the modern world are powered by software. And I will tell you that this is actually the same software that is used to power our planetarium. Whether I am in the planetarium or not, I'm not going to answer that. I'll let that be a mystery. Okay. All right. So a nice question about light pollution. Why is there more light pollution on one side of the USA than on the other? That was a really great question. And in fact, let me see if I can bring up that view again. It's really not fair, is it? Okay, so I am going to answer this, but those of you that, again, are at home talking to each other, I want you to see if you can answer this. Why do you think there is more light pollution on one side of the USA than the other? Chat about that for a second. And I do want people to know that I do see the chat windows. I'm not able to do everything at the same time, but I do see the chat windows. And I did actually see someone say in the chat window an interesting guess, but don't everyone jump in the chat. Just discuss amongst yourselves. And if anyone was saying that they think the different light pollution is due to population, yes, you are quite right. That is the primary difference there, that there is just much greater population in the eastern part of the US than on the west, although the west coast you can see is pretty densely populated as well. And in fact, in most parts of the world, when you look at the Earth at night, it does correspond to population. So you'll see that in areas that are highly populated, like Europe, you'll see a lot of lights on and therefore a lot of light pollution. You'll also see a lot in places like India and China. Japan is always bad for light pollution, but it doesn't always work out that way. So for example, Western Africa has a pretty large population, but you don't necessarily see lights on there at night. So the lights do represent places that have higher populations, but it also really just tracks where there is more access to electricity. Okay. I am going to go back to night sky, but this is fun to have all these different views. Okay. Question, can you see the Big Dipper throughout the summer? That is a really good question. Can you see the Big Dipper throughout the summer? So let's quickly take a look to see if the Big Dipper is still there right now. And again, those of you at home, can you remember which direction we should be looking in to spot the Big Dipper? I'm going the wrong way. Okay, it is north. So we're looking in the north, and oops, just a moment. Okay, have everyone got Big Dipper? Okay, so let's point out the Big Dipper again. And let's get a nice view in the north. So the Big Dipper, it's still there, but it might look like it's in a slightly different position than it was before. And you are correct. It is in a different position. And I'm going to let some more time pass. So we're going forward from midnight, and you'll see that the Big Dipper is slowly moving across the sky. But you are never going to see it set below the horizon. So the answer to your question, can you see the Big Dipper throughout the summer, is yes. You can see the Big Dipper every single night, and you can see it no matter what time it is. And that's because the Big Dipper is in the northern part of the sky. All of the constellations that we were looking at earlier are in the southern part of the sky. So, oh, by the way, everybody, it appears that that Leo is gone. So now it's 2 o'clock in the morning, Leo's gone. So the stars in our southern sky are going to change throughout the year, but the stars in the northern sky are not. And that is only true for those of us in the Northern Hemisphere. It's basically because the Northern Hemisphere is, tilted towards this position in the sky. And so this view never changes for us. Now, if we were in the Southern Hemisphere, the southern sky would appear the same all the time, and the stars in the north would change. So very good question. The Big Dipper is not one of those seasonal constellations. It's visible all year long. Okay, let's see. I have a question. Why doesn't Leo look like a lion? So I guess we don't all agree that it looks like a lion. I'm not saying I agree. So it doesn't look like a lion for the simple reason that it's not a lion. It's a couple stars. And a long time ago, people had a very big imagination. They were looking up at the stars and they were trying to see patterns. And they didn't want to be boring and just say triangle and circle and square. So they really tried hard to look for patterns, and they even made some up. And in fact, with the Greco-Roman constellations, most of them are named after characters from their mythology. So it was kind of a part of their storytelling culture that when there was a character or a creature like the lion that were very important, they would sort of put them in the stars, I've heard it described as like a celestial hall of fame. So it's part of storytelling, and like with any storytelling, there needs to be a lot of creativity. But if it doesn't look like a lion to you and you want to call it something else, that is totally okay. Okay. All right, I have a question. How do you know which direction your house is facing? Well, I think I maybe didn't explain this well earlier, but in previous episodes, I've mentioned that you should look for the moon. And once you find the moon, you're looking south. Well, you might have noticed that there's no moon in our sky tonight. In fact, right now we've gone all the way forward to 2 o'clock in the morning, and the moon is still not up. So the moon's not actually going to be visible tonight until 2:30. So you can use the moon, you can use the sun, but you can also use your phone or a regular compass. So I don't know if people can see this, but just on an iPhone, there's these compass features, and you can use that to figure out which way is which. And I definitely do recommend that you figure out which side of your house is facing south, which side of your house is facing north, and that way you'll just remember it based on the house, and you don't have to take out your compass every time. Okay. All right, I'm going to take maybe one more question tonight. A lot of good ones here. How big is Cygnus? So, Cygnus. So that's actually not the question I had thought it was. So Cygnus is one of the constellations. Sorry, I shouldn't be doing that. How big is it? It's actually an interesting question. So remember that the constellations are just sort of patterns, so they're not physical things. But I do want to make the point that, remember, you are all looking at very small screens right now. Even those of you who are really taking it to the next level, and maybe some of you are watching on your TV, maybe your smart TV is hooked up to YouTube, maybe some of you have a HDMI cable to a big screen TV, very cool. But even so, however big your screen is, it's still smaller than the sky. So everything that you're seeing here is in a way smaller than the patterns you're going to see outside. So if you wanted to look for Cygnus in the real sky, you want to look for this same pattern. And if I may point out Cygnus, Cygnus is a nice constellation. It's really just kind of a simple cross shape, so it's kind of easy to find. You want to look for that same pattern in the same area of the sky, but it's going to be much bigger in the sense that the stars are going to be more spread out. So it'll be the same pattern, but with more space between the stars. And that's always a little bit tough for people to connect what they saw on the screen to the real sky, because it's just such a bigger scale. Okay. All right, let me see if there's any more here that we can answer before the end of the evening. I have a question. Where is the star Rigel? Oh, another great star with a great Arabic name. And I'm going to address that one because that actually has to do with what we've talked about tonight. So the star Rigel is one of the stars that is visible in winter. So it's part of the constellation Orion, and that's a constellation that's visible throughout winter. So all through this entire night, we started at 7:45. It's now 2 o'clock in the morning. You will not have seen that star. It wasn't visible at all. Now, the thing is that Rigel doesn't just disappear. It is going to be visible later, but it's going to be visible during the day, or it's going to be up, I should say, during the day, which means it will not be visible because you can't see stars during the day. So that's what we really mean with some stars are visible in summer, some stars are visible in winter. They're actually all going to pass through our sky. Every star that we can see is going to pass through our sky, but some of them are just going to pass through during the day. So it's the ones we see at night is the ones we say that are visible during this season. Okay, great questions, everybody. Let's see. I'm gonna stop there because we do have quite a lot of questions still. I do want to let everyone know that we are saving the questions, and we intend at some point in the future to do a special show where we maybe answer some of the most popular questions that people are asking us. So thank you all so much for contributing questions. I want to let everybody know that during the or at the end of the Zoom, if you're on Zoom, after you leave the meeting, there should appear on your screen a link to complete a survey. And I really would appreciate it if everyone who's on Zoom would do the survey. It's really helpful to us, and you'll get a chance to prove in a really short and easy question a little bit of what you learned here tonight. All right, so that's going to do it for AstroNights tonight. We hope you will share this program with your friends when the recording's up on YouTube, and encourage them to tune in next time. All right, so thanks everyone.